So my demo is on sorting algorithms. So a sorting algorithm is essentially a set of instructions used to rearrange elements of a set into a specific predetermined order. So here I have a set of 5 cards. I'm going to shuffle it, and this represents our randomized list of data. So I'm now going to show you an algorithm called selection sort. What this algorithm does is it finds the least valued card and swaps it with the first card in the list. So it's going to go through, it's going to compare the first 2 cards, and it's going to say, okay, is 4 or 9 smaller? Well, 4 is smaller, so it's going to keep that. And then it's going to compare it to every value. Since it found a card that is smaller than 4, 4 is now going to be closed, and it's going to start comparing to 3. So when we're at the end of the list, we take 3 and we swap it with the first card. So we're going to do that over and over. Until we have a sorted list. So our predetermined order with the cards was in order from least to greatest. But what I did here is I scaled it up, and we're using an RGB strip connected to a Raspberry Pi. And each individual pixel of the RGB strip is coded to a different color. So our predetermined order, in this case, is going to be rainbow order. And in just a second, I'm going to have the computer randomize the RGB strip and then attempt to use selection sort in the same way that we did to sort this strip again in rainbow order. So here's our randomized strip, and I'm going to go ahead and start the algorithm. So here you can see the 2 white lights represent the 2 values that it's comparing. So it's going to go through, right now this is the smallest, oh, and it just found another smallest element, and you can see it swapped it over to the front. And it's going to do that over and over again, going through the entire list. Now I'm going to speed it up a little bit just so it goes a bit faster. So you can see it's doing that over and over again, and you'll start to see the rainbow pattern forming at the beginning as the elements are getting swapped at the beginning. And the algorithm has completed. So another algorithm I can show you is called insertion sort. Now this works a little bit differently. So we're going to start over here by comparing the first 2 cards, and we're going to say, okay, is 7 less than 4? Well, no. So then this is a sorted list. Now we flip another card and we say, okay, is 6 less than 7? Yes. So we swap, and is 6 less than 4? No. So we stay. So essentially it works by finding each card's new place in the sorted list. So we're going to keep going, swap, swap, swap. And then this one's in its place. So insertion sort has a pretty similar runtime to our selection sort. So we're going to see it in action here on our LED strip. And you can see it's finding each element's spot into the sorted list. We're going to speed it up a little. So the light is moving this way because it's swapping and comparing those elements. And as you can see near the end of the algorithm, it gets slower and slower to find each element's spot in the list. Thank you for watching.